Welcome to data analysis with Python. In this sixth video and overall like 17th or 18th, we'll be looking at the idea of data transformation and feature engineering. Data transformation and feature engineering. So first we'll look at the definitions. Data transformation, for instance, talks about converting raw data into a suitable format or structure for analysis, and it involves things like normalization, scaling, or encoding to enhance model performance. This is particularly in the context of machine learning. Of course, it has a use case in data, just basic data analysis too. So feature engineering is about creating new input features or modifying existing ones to improve machine learning model accuracy and interpretability, typically by leveraging domain knowledge or data insight. So as you're doing feature these kind of things, you need to understand the context of the data set you're working with. So in this case, again, I've chosen to use the supervisor's data set. It's a very, I made up the data set myself. It's a very useful data set for learning data cleaning and all that. Of course, you can find more. You can find other data sets on Kaggle and all of those places. So I'll be using this. So once each time I do these things, you can also just go on Kaggle, find a data set and do something with it. Or better still, since you have access to all the data sets on my code sheets, so you can just check the description box and download all the data sets. So if I do something with the supervisor's data set, then try and do the same with other data sets that I've not done them on. And but be mindful that I have all kinds of formats. I have Excel, I have CSV, I have JSON. So be mindful of the one you are using. And in tackling this kind of challenges, you're going to really learn because just like I keep saying, the best way to learn coding is to really code. So if you watch long videos and you're not implementing as alongside what you're watching, by the time you are done watching the videos, you may be too tired to even implement anything, and you have not really learned anything until you have started coding for sure. Okay. So, to upload the supervisor's data set, right? Since it is an Excel, it has an XLSX, meaning it's an Excel data set. And just like I like to do, I like you to see the data set. I mean, I always advise once you have a data set, open it first in the original form. So this is the original form. Like I said, just made this up. So it's looking like maybe you have a corporation or a multinational, so to speak, where you have staff across different parts of the world like that. So this is what this looks like. You can see there are obviously missing values and all of these things. So you may need to do all the cleaning up. So I already brought that up when we're talking about data cleaning. So I may have to repeat some of those concepts here because just like I said, some of these concepts overlap, like data cleaning, preprocessing, feature engineering. So sometimes you may have to do them at the same time. Okay, so back here now. So I want to upload this. So you see, what we just seen is the Excel sheet. So by reading, by saying pd dot read underscore Excel of that document, you're automatically converting it into a data frame named DF. You can, just like I said, you can name it data frame, you can name it anything, you can name it, give it your name, you can call it data, whatever you choose. But DF looks, it's like instructive, it's data frame. So I just run this and it gives me the data set. So of course, the other alternative is to say print DF. And just like I said, print DF is usually not as beautiful as what you get without using the print command. But the thing is that if you have to print with, maybe you have many data, maybe you have many lines in each cell, and you have to, you cannot use the ordinary DF. You have to use print in that case. So imagine if I use print now, you can see it's not. Of course, it's still okay, but then it's not as beautiful as if you just call the DF alone. And just like I said, if I have other lines of code after this DF alone will not work. So uh, print is the default thing. But if you want it to look a bit more organized, then DF like this works. So you can see what the data set looks like. It's a data set with 22 data points numbered from 0 to 21, and it has six columns, name, gender, age, city, salary, and staff. Of course, you can do your exploratory data analysis. I've already explained that, so I won't go into that too much. for now. I mean, at this point, right? But you can use .info, you can use .describe to get an overview of the data set. So you can see some NANs and everything. So before you even begin any analysis at all, you will have to clean it for sure. And that's what takes us to data cleaning, which we have treated in I think two videos before now, but I think it's okay to talk about it again. So I'm just going ahead to drop, and just like I keep saying, once you import pandas as PD, you don't have to do it again. And once you mount the data set df in line 3, you don't have to do it again, except if you have done some operations and you want to revert to the original thing. In fact, it is advisable, right, that if you want to do something with the same data set, you may have to copy it out, and all of that is implemented in this session. So for data cleaning, we are just going to drop all the missing data. For instance, anywhere you see NaN, like in line, I think the first NaN is in line 6. We have a missing city in line 8. Oh yeah, I forgot to zoom. I forgot to zoom. Yeah, I think this helps better, right? So this is what I implemented to get this data frame right here. Okay. Then when we come here, we're talking about data cleaning. So I just want to drop missing data. So to drop missing data, so that df that we have up there, this df we mounted here, want to drop any value, anything that is missing. So you can see all these NaNs now, they are missing. They are missing values there. Like I said, the first one is the information about Giorgio, missing, the city is missing. Then you have Malema, the city is missing, and of course the number of staff under, this is a supervisor's data set. So we have supervisors with the number of staff under them and think their salary and the rest of it like that. So you have Malema, no staff number we don't know. You have Noriko, no staff number. You have Pavlov, no staff number and no salary. We also have and all that. You also have William, no salary, right? Then we have number 20, we don't know the name, but we know the person is based in Dresden, Germany. And of course, we have some repeated names like Pierre, Priya, and Ying. So, but for now, we are dealing with dropping missing data. So the main thing, we've done this already under data cleaning. So this serves as a kind of reminder for you. So to drop missing data, just say, so we are now saying that the DF we had before should be, so we want to drop all the missing, not available values, and then we still call it, we'll maintain the DF. So it may be useful to, just have a copy of the DF yet before we drop the value, but it's okay. Like if we need the data again, we just mount it at any point when we need it again. So here, I want to drop all the not available values. So watch out, everything that is NaN here, by the time we implement that code, we are not going to have all of them. So Giorgio number 6 will be gone, and all those other places where you have NaN. So since I have expanded, I'll just use the shortcut to run, which is Control Enter. Okay. So with Control Enter now, you see number 6 is gone. So we have 0, 1, 2, 3, 4, 5. No 6 anymore. We have 7, no 8, no 9. We have 10, no 11, no 12. We have 13, 14, 15, 16, 17, no 18. And now we have 19 and 21. So we have dropped every missing value. Of course, it's not always that easy to just drop missing values. In your case, you may have to replace missing values. At the end of this whole session, at the tail end of this Jupyter notebook, I've put a very comprehensive example there that involves maybe you having to replace on no sometimes. So you may choose to delete missing values, or you may choose to replace them, because as an HR person, you want to be careful to just delete data points like that. So you have to be very careful with that. But here I've just chosen to delete. So another thing is to drop duplicates. So you see, we have 3 pairs, we have 2 priyas, and we have 2 yings. Now they'll be duplicated if when we know we have duplicates is when all the names, maybe you have a particular data set with everything just the same, like Pierre, this first and second Pierre, they are basically the same, and this Ying and the Ying, if the like this Pierre now is different from them because the other two have 12K salary, 120K salaries, but this one has 210,000. So it will be, Python will treat this as different, even though even that may be a mistake, right? But as far as there's one data that is different, right? Python does not take it as a duplicate. So for these last 2 yings too, we have to delete one because all the information at every point is the same. So for this Priya, we can basically treat them as separate people because there's this prior who earns 35,000 and there's another prior. Although every other okay, we have two information different. Once an information is different, Python does not treat it as duplicates. So we drop duplicates now. So watch out for one Ying is going to go and one Pierre is going to go because they have exactly the same information at every point. So control enter. So you see now further, you see the duplicates are gone. So the third pair, or the second pair is gone. Pair was at number 14, it's gone. Ying at 20 is also gone because Python sees them as sees it as a duplicate. So now we have 0, 1, 2, 3, 4, 5. Yeah. So we have 0, 1, 2, 3, 4, 5. No 6, we have 7. No 8, no 9, we have 10. No 11, no 12, we have 13. No 14, we now 14 is that Pierre, that second Pierre who that has exactly the same record as the number 13 Pierre. 15, 16, 17, 18 was Ying, right? And now we have 19 like this. So you can see the numbering is not following, right? So but then let's leave that for now. So the next thing we also do under everything I've been doing so far is under data cleaning, like dropping missing data, dropping duplicates, and handling outliers. That's still under data cleaning. So we did an example of handling outliers using a method called Windsorization or trimming. So where you use the quartiles, you use the first quartile, that's the 25 percentile, you use the third quartile, the 75 percentile, as you see in line 7 and 8. And then you talk about the interquartile range where you subtract the first quartile from the third quartile, and then you now create boundaries. You have a lower bound, which is the first quartile minus 1.5 times the interquartile range, while the upper bound is the third quartile plus 1.5 times the interquartile range. So you use that to set the boundary. So anything that is below the lower bound or anything that is above the upper bound will be beaten, will automatically take the values of these bounds. That's how this winsorization thing works. Okay, so here now you now have okay, you now print the lower and upper bounds are. So if you remember print under basics of Python, right? So this is F string. This is F string. So whatever lower bound is, it just automatically shows up there. And then we have the last one, now clip outliers in age. So anything that is above the lower bound, above the upper bound and below the lower bound will automatically take their values, right? Anything below the lower bound takes the value of the lower bound. Anything above the upper bound takes the value of the upper bound. And that is what that is about. So I just press enter and we have this. So you see, before now, we had this Ayumi, who was 105 year old. Now Ayumi is 44.5, which is automatically the value of the upper bound, right? The lower bound is 16.5. So we don't have anybody less than 16.5. So we don't have anybody taking that value, right? So that way we have also handled the outlier. So no, because we know outliers affect results. So one more thing we want to do in data cleaning is to, so you see the numbering has now been scattered because of the things you have dropped and and all that. So you can also reset index. So to reset index, so reset data index and drop old index. And the way to do that is just to say the old DF you use now is equal to that old. So the new DF now that you're going to have will be equal to the old DF with reset index, and you drop the old one. And then by the time you read this DF, you are going to get renumbered stuff. So from here now we have 0 to 19, and the data set is not up to 19 for sure. I think everything is like 13. So by the time we run this, we now have 0 to 12, right? So now this is your clean data, so to speak, with 13 data points numbered from 0 to 12, because numbering in Python is from 0 upwards, right? So now, so you can say you have cleaned the data like this. So you can now proceed to do other things. But our focus in these videos in this particular video is on feature engineering. And just like we saw already, feature engineering is all about creating new columns or creating new ideas from what you already have. And sometimes it may be necessary. For instance, you want to you are doing a research on people's weights, and you have their height, you have their weights, you have their heights and you have their weight, yes. And from that, you can calculate the body mass index, right? Which is, I think, weight over height raised power 2 or something like that. So from this supervisor's data set now, you may be interested in creating a new feature by combining. So one of the ways you can do feature engineering is to create a new feature by combining existing features. So we may be interested in, say, okay, we have uh each supervisor's name is here, and we have the salaries they collect, and we have the number of staff. So can we say, okay, can we just do a calculation like, is it possible to, can we know the salary if we divide a supervisor salary by the number of staff they supervise? So that will give us a kind of measure like salary per staff. So as a supervisor, this is the salary I earn per staff that is under me, something like that. So, and that is what exactly we are doing in this place. So we are creating a new feature by combining existing features. So the existing features are salary and staff. So salary per staff will just be, so you now call salary from the data frame divided by staff from the data frame. So that's salary per staff. So, and this round now, just like what we have in Microsoft Excel. So this round now will help us round the value to two decimal places, because, we are talking about salary and it's about money, and money is usually in two decimal places. That's why I'm doing this. Okay. So if I run this now, it gives us, so we now have, so this DF salary per staff is a new column. So by doing this, this is how you add a new column to an existing data set. Okay. So now you have the salary per staff where you have salary 45,700 divided by 20. You have this 55,000 over 9. This is what you have. 111,000 by 13. This is what you have, and so on and so forth. So this is like the salary per staff in this case. So for Ying, the salary per staff is 25, well, whatever, maybe dollars or or anything. So, and so, like that. So you can create a new feature by combining existing features. So it's more like distance covered, and you have time. So you can calculate the velocity or speed of a car in case you're dealing with data from cars like that. Okay. So another way to do feature engineering is to transform a feature using a mathematical function. For instance, you have staff. Maybe you have a measure like, okay, we once your staff once you have square of the staff you have, by the time you became a supervisor, we promote you. Maybe promotion criteria is when the number of your staff gets squared. I mean, that's just something I made up. So in that case, we now want to create a new column called staff squared. So that will just give us, and we can only get square from NumPy. I suspect we are going to have an issue. Oh, we are not going to have an issue here, because when we did that outlier thing, yeah, I already imported NumPy here, because we are using NP in line 17 here. In this line 17, we have to use NumPy, because clip is a function inside of NumPy. So that's why I imported NumPy here. So I didn't have to import Pandas again, but here I need NumPy. And since I've imported NumPy here, I don't need to import it elsewhere. So I was already going to think we are going to have issues, but since we used NumPy before, no worries. All right, so here, this is where we are now. So to get square is a function inside of NumPy, and that's why I'm bringing this up. So we are creating a new column called staff squared, and it is going to be from the square of the number of staff. So if you look at all this number of staff now, so Adamu is going to have 400 staff squared. Yeah, Adebayo is going to have 81. Ayumi is going to have 169, and so on and so forth. That is what this is going to do. So if I just press Control Enter, this is, so we now have another column called staff squared. So what we're saying is that once you started with 20 staff, once uh whatever, like, I'm just trying to make stuff up. Like maybe once your staff reaches 400, or if you calculate, or maybe there's a bonus you get, and it is calculated based on the square of the number of staff you have, whatever. So anything you have in your situation, that would inform the kind of transformation you may have to do. Okay, so that's another way to do feature engineering. Another way to do feature engineering is you may have to bin a numerical feature. All right, you may have to bin a numerical feature. For instance, for staff capacity, right? So you can see somebody is handling 20 staff, another person is handling as high as 34 staff. So you may want to categorize supervisors based on the number of staff they handle. You can now say, okay, from if you handle from 0 to 4, 0 to 15 staff, then we say that you are a low level supervisor, so to speak. If you handle from 15 to 30 staff, you're a medium level supervisor. If you handle from 30 to 45 staff, you're a high level supervisor. So Beaning can do that for us, and this is the code for that. So you want to create a new column called staff capacity, and that staff capacity now, then you speed it dot cut, then the staff you have now, you now bin the staff because you have the staff number. So anybody from 0 to 15 will be designated low, 15 to 30 will be medium, and 30 to 45 will be designated high. And by the time we visualize the new DF, you're going to see that we have a new column called staff capacity with all those bins, so to speak. So now we have that. So these are new additions now. So this is feature engineering going on here. So we have done 3 steps of feature engineering with salary per staff from salary and staff that we had there before. Staff squared using a mathematical stuff, then staff capacity now using binning. So you see, this person has 20 staff. So the person is a medium capacity supervisor because the staff is between 15 and 30, and this one has 9. So this is a low level supervisor. This one has 13, which is between 0 and 15, low level, 18 medium, and so on and so forth. So this person has 34, that's high level staff. So of course, usually the higher you go, the fewer people become, right? So we have only one high level staff here. So we can even assume that that person is maybe the top boss or something like that, so to speak. Okay. So another way to do feature engineering is to encode a categorical feature. Sometimes, especially in machine learning, you want to you want to do a machine learning model, right? And then you don't want to use numbers. You want to use categorical variables. Of course, they're already categorical, but then you just don't want to use male and female, or maybe medium. Even that low, medium, high we did, we could also encode it as a categorical feature. So in that case, now you can have encoding. So but when we get to machine learning, we are going to talk more about, or maybe what I'll call data science. I don't know. There you can now begin to learn about different types of encoding, hot encoding, and things like that, or one factor encoding and whatever that is. So here, basically, we are saying that all the gender now, male and female, those are the only two gender we have here. So for the gender code, you just say male is 0 and female is 1. Or in another case, you can say male is 1, female is 2. Anyhow you like it, just define your rules. So this is the fourth way to do feature engineering. Of course, there are many more ways to do feature engineering, but these are the 4 I've captured in this case. So if I run this now, you see we have so now the gender code, anywhere Adamu is male, that's 0 for the gender code. Adebayo is male, that's 0. Ayumi is female, that's 1. Brian is male, and so on and so forth. Ying, the last person, is female, and the gender code is 1. Okay. Now, so as a data analyst, right, you started with that data that had missing values and everything, and now at this point you have done uh, cleaning, you have done feature engineering, and once you are done, right, you want to do something with this new data you have, because now this is a reliable data that you can now analyze, you can work with, right? So that's why I'm talking about new data in this part. So the first thing is you want to export that refined data. So up till this point, right, our data is called DF. So mind you, be sure what you want to export. I mean, what you want, yeah, be sure what you want to export. If you have given it another name, be sure it's that name you call here. So I've maintained this DF all the way so that it will be easy. So of course, to export refined data now, it's more like you want to write data in a particular format of your choice. So here I'm writing that data we have up here. By the way, let me see. Do we have refined supervisors data here? Probably. But if we have it, I'm going to delete it. So you can see that you're going to create it on your own. So uh yeah, I think it's gone now. Okay. So we don't have that. So when I go back now, so to export this refined data you have now without errors, with feature engineer, that is feature engineer, so to speak. So if I just run this now, if I just run this, control enter, so it's not giving, it has not given me any results. But once it doesn't give you error, it means that it has done what you want it to do. Once it shows this number, it has written it, and that's pretty fast. So when we come here now, you can now find your refined supervisor's data. So by the time you click it, it's an Excel file for sure. So you see, look at what it looks like. So you now have name, gender, age, city, salary, staff, you know, uh, salary per staff, staff squared, staff capacity, gender code. So if all your work here is just to, is just to do this and send it to another office, so you can just go ahead with that, right? And you may also want to add anything you want to do with this. Maybe your own job is just to clean data and send it to the office where it will be useful. So with this now, it's neat, and you can just transfer it to the office that will need this, right? So now that is our feature engineered data. So now that we have that data written, we can now we can now read it, right? We can read the refined data. And so don't forget the name you called it. We said it's refined supervisors data. So we started with just supervisors data. Now we have refined supervisors data. So having cleaned, having feature engineered, and all that. So, and here I'm choosing to call it not just DF, I'm calling it now DF underscore refined. I could still call it DF if I like, but just to be sure, it's another kind of data set. So we have DF refined is now, you don't want to read the data now. It's more like you're importing the data. So you have pd dot read underscore Excel refined supervisors data. So one way to show that it's already there in your folder, even if you did not see it, is if this does not give you error and it gives you the data set. So I just press Control Enter. Now you see the data set is actually available now. So there's something called that. So you can now go ahead and do exploratory data analysis, which you're already used to. So first you can check first five data points, Adamu Adebayo, Yumi, Brian, and Chand. You can check the last five data points, that will be Pierre, Priya, and Ying, like that. Then you can do a data overview. You just want to know the number of rows and number of columns in the data. We've done this before under exploratory data analysis. So I'm just trying to rehash some of these things, right? So here we know we now have like 10. The original document had like it had just 6 columns, I think, but now we have 10 columns because we have some feature engineered columns, right? And now the memory usage is like 1.1 plus kilobytes, still very small. Then you can also have a data statistics, like by using the describe function. So this tells you the statistical distribution, so to speak, of the data set for the numerical things alone. Anything that is not numerical, like gender, you won't find gender here, for instance. But for gender code, which is not a number, it's giving something. Though this may not make it doesn't really make any sense because that gender code is more or less object, but it's okay. So for age now, you can see now we have, unlike the initial case where Ayumi was 105, the minimum age here is 18 and the maximum age is 44.5 because we have handled the outlier age 105 because it's going to affect the system, right? So the average age of people in the company is 30.73. Then average salary is 102,953 point all that. The maximum salary is 210,000. The minimum salary is 200. So the number of staff, you have all that. So the minimum mean average number of staff is 17.38. You have, and then this one, all these 13 show you nothing is missing because we have removed all the missing values, right? So and so on and so forth. So now this last one now, I won't worry so much about it. I just put it there so you can see another approach. So this is a very comprehensive another comprehensive way. So it's totally independent of what I had done before. But I'm still using the supervisor's data in this case. So this is a totally comprehensive way insight into feature engineering. So by looking at this again, you can also see some things I didn't really talk about previously. You can find them here. So I'm seeing some transform and all this here, group by. So you can also use this. So by the time you add what I explained thoroughly with this one now, you can see you can really get the gist. So let me run this one too. Control Enter, and then you have this comprehensive thing here. So here you have more things: name, gender, gender code, age group, salary, is high earner. So, like, do you want to or even find out now, is this who is a higher earner? So you set a criteria, a rule for who is a higher earner, just like we did for the staff capacity. Is the person managerial based on the particular level of thing? Age group, is it adults, young adults, or elderly? All that. You can talk about salary per staff. Okay, I think I did that. The name length, what's the length of the name? The city frequency. How many people? How frequent is that city in this data set? Like, or maybe you just want to know how many people are in that city. So by just looking, Lagos is you have Lagos showing up three times. City region, Africa, North America, all that. Is it duplicate, false? So you can do so many things. So by combining all this together, you get it. And just like I keep saying, right, you have access to all the data sets I'm using. You have access to my code sheet also. So if I've done something with a particular data set, you try to do, uh, just let your imagination run wild and do the same thing or even more with other data sets in my folder that you can access through my description box on YouTube, so or even on Facebook for sure. So download all the data sets and do the same thing I have done on this data set on other ones I did not do it for. But be mindful that they're not of the same format all the time. So you may have a CSV or JSON file. So be mindful of that so you don't have issues reading and writing and all that. Yeah. So with that, we come to the end of this interesting video on data transformation and feature engineering. Let me know how helpful this video is for you. Let me also know if there's a topic you'd like me to teach or a problem you'd like me to solve, or you have a data set you would like me to work on, which you can send, or if you give me an idea, I can make up the data set, maybe in your particular niche. I can make up a data set and then I'll use it as a kind of project to explain, and then you can draw some insight from that. All right. So if you have not subscribed, of course, by now you'll be missing a lot. But if you subscribe, don't forget to hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content we have going on here. I have tons of mathematics lessons already here. So now data science is coming into it. Data analysis is coming, and I hope to escalate it to say data science, machine learning, and all that. Okay. So till I come your way again, keep doing data right. Bye.